Now that we know how to use the decision structures, we can solve more complicated problems. And be careful, writing these programs becomes harder. And then here, we suppose we need an algorithm to find the largest of three numbers. And let's look at the starter code. In starter code, we'll ask for x1, x2, and x3 as three different values. And then we'll write a code that sets max val to the largest of the three. And then we can print largest value is max val. This looks like a three-way decision where we need to execute one of the following. So it's either x1 is max val, x2 is max val, or x3 is max val. So there are a couple of different strategies we could use to solve these problems, and let's look at the first one. Strategy 1, compare each to all. So first we can assume that x1 is the largest. So in that case, x1 must be greater than or equal to x2, and x1 must be larger than x3. In that case, max value is x1. If not, we can create a case for x2. So in this case, x2 is greater than x1, and x2 is greater than or equal to x3, and that in that case, max value is x2. And if not, if it's not x1, if it's not x2, then it must be x3. So here we use the n to separate the conditions, and we're comparing each value against all the others to determine which one is the largest. And let's try this. And now let's test our first strategy. So I've saved the file as maxval.py, and I save it in lecture 6 folder. Alright, so let's get our starter code. So we'll ask for x1, x2, and x3, and we write a code to set max val to the largest of the three numbers, and then here we're going to print. So again, our first solution was if we're going to build a case for x1. x1 is greater than or equal to x2, and x1 is greater than or equal to x3. So in that case, max val is x1. So we have an if this time x2 is greater than or equal to x1, and x2 is greater than or equal to x3. That case, max val is x2, and else max val is x3. So let's go ahead and test this. So enter number 1, let's say 1, 2, and 3. The largest value is 3, and we can try this again. Let's say 3, 2, 1. Largest value is 3. Let's try one more time. Let's say 1, 3, 2, and the largest value is 3. So this was a good solution, but what would happen if we're trying to find the max of 5 values? So this solution becomes not so much scalable. Strategy 2, decision tree. We can create nested if structures to solve this. We can compare at most 2 values and eliminate one of them. And then here's the solution. So first, let's compare x1 and x2. So if x1 is greater than or equal to x2, that eliminates x2. Then we can check whether x1 versus x3. So then a nested if x1 is greater than x3, in that case, max value must be x1, else max value must be x3. If this is not true, then we can check the case for x1, x2 compared to x3. So if x2 is greater than or equal to x3, then max val is x2, otherwise max val is x3. And let's try this. And now let's test our strategy 2. So here we have if x1 is greater than x2, and in that case we check whether x1 is greater than x3 or not. Else, then we check the case for x2. And let's test this one. All right, so ask for 1, 2, and 3. The largest is 3. Let's test one more time. 3, 2, 1. Largest is still 3. And let's say 1, 3, and 2. The largest value is 3. So here was our decision structure. So first we compare x1 against x2. If the answer is yes, we went through what if x1 and x3. If not, we went through what if x2 versus x3. So, and then each branch has its own decision tree here. If x1 is greater than x3, we assign max to x1. Otherwise, we assign max to x3. And then likewise, we did the same strategy here. So this was a good solution as well. But what would happen if we're trying to find the max value of 5 values? Again, this is not a scalable solution. Strategy 3, sequential processing. This process is repetitive and lends itself to using a loop. So we will assume that the first number is the max, and then we can compare the next against the largest. If you find the new max, we can replace it. And here's the solution. So first we're going to assume that the x1 is the max val, and then we'll see if x2 is greater than max val or not. In that case, we have a new max val. Otherwise, we'll check x3 is greater than max val. If that's true, we have a new max val x3. And let's try this in the editor. And now let's check the strategy 3. So here, we're going to assume that x1 is max val. Then we're going to compare x2 against max val. If this is true, we have a new max val. And then we can check x3 against max val. If that's true, we have a new x max val. So let's test this one. So 1, 2, and 3. So largest is 3. 3, 2, 1 still works. And then 1, 3, 2 still works. And here's the flow chart for our program. So first we assume that x1 is max. Then we compared x max against x2. If that's true, we have a new max. Otherwise, we compare max against x3. If this is true, we had a new max, and we went on. And this was a good solution. Also, is a very scalable because we can create a loops to check values that are more than 3. And finally, let's create a scalable version of the strategy 3. So very first thing I want to do is I want to save this as maxn.py. Okay, so the first thing is I need to ask user how many numbers there are to enter, and then I can here. So all right, so I'm gonna assume that I'm gonna ask the first value and I'm gonna assign it to max val. So I'm gonna say int input. I will say enter a number. So I'll automatically assign that number to max val. Now I need to create a loop for I in range. Since I've asked the max value, enter the first value already, so I'm going to ask one less, so n minus 1. In that case, so let's create an x. X is sort of the same thing, enter a number. Then I'll create an if statement if x is greater than max val. So in that case, we have a new max val, that is the x value. Then we're going to continue asking for this, and at the end when the loop is done, we can print the largest value is max val. So let's test this program. All right, so we have three values. So 1, 2, and 3. So the largest is 3. So let's also make sure that we change this one to find the maximum of a series of numbers. And I'm gonna run this again. This time, let's test for 5 numbers. So 1, 2, 3, 4, 5. The largest value is 5. Let's say one more time. I have 5 numbers. So 1, 8, 3, 6, and 9. So the largest value is 9.